All right, so I think this is recording. Let's take a look at some of these application problems that are now wanting us to write absolute value equations here on the first few. So uh, a car landed 12 feet from the spot that the wreck started. So let's say that we have some road, and at this point on the road is where the wreck occurred. Now, a car is not going to hang in the air when it say that it's landed. That the two spots now for the car are 12 feet from this wreck, either 12 feet forward, and the car could be right here, and it's probably mangled up, or 12 feet behind the spot of the wreck. It could be back here, and like we say, it's mangled up. All right, so to write an equation, if we let x be the distance from, let's call it the wreck spot, and that's in feet, we want to write an absolute value equation. So we're treating this wreck spot really as the origin. And remember, absolute value is the distance from the origin. So the equation that represents this problem, if x is the distance from this wreck spot, is the equation, the absolute value of x equals 12, will give us two solutions. One where x is equal to negative 12, and one where x is equal to positive 12. Now, normally, this negative 12, I guess I should really rephrase the word distance here, because yes, the 12 feet, it's more of a location than a distance, because we know that distances can't be negative. So negative simply in our picture means to the left, and positive means to the right. So maybe this road was a northbound, southbound road. So 12 feet north of the wreck or 12 feet south of the wreck are the two possibilities of where the car landed. The problem isn't specific as to which one. All right, so let's do another one here on this same video. We've got Joey's golf score was 4 strokes from his average score of 89 on an 18-hole course. Well, the 18-hole course is extraneous information. I really don't need that. Let's take a look at his score, well, his average score. And normally when Joey goes out, he scores pretty close to 89 strokes. Well, he was on this particular day, he was 4 strokes away from that 89. Now, it's not telling us whether he was 4 strokes under or 4 strokes over. So he could be out here a distance of 4 strokes above his average. It could have been a bad day, because in golf you want a lowest score. You want to hit it in the hole in a fewer amount of strokes than your opponent. Now, it might have been a good day, and he might have got a score lower than his average score, but we don't know. Okay, so if we let x equal his score, now not his average score, his score for this specific time they went golfing, for this specific day, an absolute value equation that we can solve to get this score is x minus 89 is equal to 4. Okay, so you always pick your variable x is here or here. The 89 is in the middle, and the 4 is the distance from that center, because we're calling this the new origin, the center. All right. So this can be solved as x minus 89 is equal to negative 4, or x minus 89 is equal to positive 4. So let's add 89 to each side. 89 minus 4 is 85. 89 plus 4 is 93. So here is the equation that represents it, and here are the two possible scores, strokes, that Joey could have scored according to the wording of the problem. I'm going to go ahead and do another one on this same video. In a science class, an experiment showed that the stated temperature differs from the actual temperature by exactly 1.5 degrees. Write and solve an absolute value equation to find the maximum and minimum actual temperatures when the thermometer reads 87.4 degrees. All right. So we have two types of temperatures. We've got a stated temperature and the actual temperature. Okay. So when this thermometer is reading this 87.4 degrees, boy, that's actually, assuming that thermometer is accurate, this 87.4 is an actual temperature. Okay. So let's let x be the stated temperature, which I'm assuming means our educated guess. It's not the real thing. By degrees, I'm going to go ahead and just say that it's degrees Fahrenheit for myself. It could be degrees Celsius, but it doesn't say. All right. The difference between the stated temperature and the actual temperature, which in this case is 87.4, that difference, your guess is pretty close to the real thing, to the accuracy, because it says the difference is 1.5 degrees. So usually when we state the temperature, when we guess at what it is, we're either 1.5 degrees below what the actual temperature is, or 1.5 degrees above what the actual temperature is. So let's solve this equation and look at a number line and see if that makes sense. So we've got x minus 87.4 is equal to 1.5, or that x minus 87.4 is equal to, let's make this one negative and this one positive. Okay. So 87.4, I don't want to make a silly arithmetic error, 87.4 minus 1.5, and that's 85.9. And if I add, instead of subtracting, if I add, I have 88.9. So I believe that the 85.9 less than or equal to x less than or equal to 88.9, and if we called it Fahrenheit, but it could actually be some other units of temperature, but it did say degrees, so I'm just assuming degrees Fahrenheit. All right, so let's see if that makes sense. Let's check our answer and see if I draw a number line here, if 85.9 is my minimum, and if 88.9 is my maximum, let's add these two values and divide by 2 and see what the middle is. I believe it'll be 87.4. So if I have 85.9 plus 88.9, and I divide that by 2, 87.4. Okay, so that's, in this case, that was the actual temperature, which when we state what our guess is of the actual temperature, we might be a little bit high. So I believe this difference is going to be 1.5. If I take 88.9 minus 87.4, oops, 1.5. And the same thing, if you take 87.4 and subtract 85.9, 1.5. So you're 1.5 units away. So hey, this is a good answer. All right, so I'm going to make others on other videos. So I hope that helps.